For years, the cold card was considered the gold standard for cryptocurrency security. It's an air-gapped hardware wallet, a physical device that stores secret keys on a chip that never touches the internet. But beginning in late July, attackers emptied more than 4,500 of these specific wallets. They drained an estimated $88 million in Bitcoin without any malware, without phishing the owners, and without a single physical theft. This happened because of a naming collision between two random number generators in the device's code. The wallet silently defaulted to a weak generator, falling back to using the chip's own serial number to build keys. That error made keys mathematically predictable. For 5 years, it quietly generated guessable codes for thousands who believed they were untouchable. Because Bitcoin keys cannot be rotated, victims had to move their funds to entirely new wallets. But attackers were watching the public network to outbid these rescue attempts. To save their money, owners had to bypass the public blockchain and send transactions directly to private mining companies, trusting a middleman to act as a digital bodyguard. The air-gapped and open-source labels offer no protection when the foundational code contains a silent flaw. If the math used to build the lock is predictable, the physical thickness of the door doesn't matter. We are currently seeing this same trade-off in the AI industry, as developers use techniques like attention pruning and distillation to make models run for pennies. The priority is shifting towards speed and cost reduction, often at the expense of verifying the underlying logic. This creates a gap called evaluation blindness. We rely on standard benchmark tests to tell us if a model is safe, but these scores are increasingly failing to predict how a model will behave when it leaves the lab. In a recent study on AI failures, 53% of systems showed completely normal internal readings right up until actual harm appeared. Scoring design also masks flaws. In World Cup predictions, model confidence had zero link to actual accuracy. When a system is designed to look functional even while it is failing, a high test score becomes a dangerous illusion. It gives us a sense of security in a structure that is already crumbling. This misplaced confidence has immediate financial consequences. Because modern AI is so fluent, it tricks human reviewers into assuming that if the output sounds professional, the logic must be sound. In October 2025, the consulting firm Deloitte had to refund the Australian government roughly $63,000 for a report written with GPT-4o. A university researcher found the AI had fabricated federal court quotes and cited research papers that didn't exist. The error was only caught after the report was delivered. Because the text was written with perfect grammar and tone, the human staff missed the fabrications entirely during their review. This failure of oversight scales to the largest platforms on the internet. Even with billions invested in AI moderation, the systems designed to flag prohibited content are struggling to catch fundamental safety violations. A report from the Tech Transparency Project found that Meta hosted and ran dozens of paid ads containing AI-generated child abuse imagery. These ads passed through Meta's automated review systems and reached thousands of accounts over a 9-month period. Even our private assistants are vulnerable through agent memory. A study showed that as an assistant learns your habits, its repeated answers can slowly reveal your private traits to anyone who asks. From high-level government consulting to social media ads to private conversations, we are vulnerable because we confuse fluency with safety. Since we cannot guarantee that any model is perfectly safe, the focus is shifting toward containment. The goal is no longer just building a better AI, but restricting the blast radius when the AI inevitably fails. We see this in Cloudflare's new operating system. Instead of giving AI agents full access to a company's network, the system assigns them zero permissions by default. Agents only reach data through pre-approved connections, with gatekeepers policing every action, so AI never accesses raw passwords. The system tracks what each agent accesses and blocks lateral sharing, preventing a leak from spreading across the company. Real security in the AI era requires moving away from unquestioned trust. We have to build systems that assume the AI will eventually lie or break, and lock down the perimeter before it does.